Solutions for perfect problem 5 from Math 112. There's this little story problem, and so I went ahead and drew a picture because I'm kind of a visual person, that we have this triangular mountain. Okay, I don't know if that makes sense that we'd have a two-dimensional mountain, but whatever. A triangular mountain, it's between you and me, so here's me, here's you. And its angle of elevation from me is 45 degrees. Well, its angle of elevation from you is 30 degrees, all pictured here. The other information given in this problem that will be really important is that it's a 100-kilometer hike from me to you. And what I mean by that is if you go up the mountain and then down the other side, you've traveled a distance of 100 kilometers. That's kind of hard to incorporate into this picture. Like 100 should go somewhere, but where? I mean, it's kind of this plus this is 100. So you could introduce two different variables, like an x and a y, and then say x plus y is 100. But a more clever way to do it is to arbitrarily name one of these lengths x, or whatever letter you choose. So maybe I'll call this x right here. The distance from me to the mountaintop is x. And if this is x right here, and the entire hike is 100 kilometers, then kind of the leftover, 100 take away whatever this is, in other words 100 minus x, would be this length over here. And if you add that to your pictures, it'll make things a lot easier, because eventually what we're going to be trying to do is draw right triangles and figure out side lengths and such. And what I just did is came up with algebraic expressions for two of the side lengths. So with this picture in mind, we can solve for a few things. The first thing is, how tall is the peak of the mountain? So what that's saying is, if you were to draw this line right here that's perpendicular to the ground in this assumption, how long would this line be? Then, I don't know, you might call this h for the height of the mountain, but then that might confuse you later, and you might think that h is hypotenuse. So I'm going to go ahead and call this m, whatever, is this length right here. And later on, it'll be useful to know more stuff, but maybe for now, I'll just leave my picture like this and start figuring stuff out. So the first thing that I can figure out is looking at this right triangle right here. There's two lengths, this x and this m. And really, I want to know what m is equal to. And since this length m is opposite this 45-degree angle, and the hypotenuse is of this right triangle is x, I can use my trig function that relates together opposite and hypotenuse, which is the sine. You might get that from SOHCAHTOA, if that's one of those things you know. To say that the sine of 45 degrees must be equal to opposite, which is m in this case, divided by hypotenuse, which is x in this case. And for my unit circle, I know that the sine of 45 degrees is root 2 over 2. So really what this is telling me is that m divided by x has to be equal to root 2 over 2. And I can do something very similar over here because I again have a right triangle. Now I want to relate together the opposite side and the hypotenuse of this 30-degree angle. So I would say that the sine of 30 degrees is equal to the opposite, in this case m, divided by 100 minus x. And since the sine of 30 degrees I know is equal to 1/2, I get that 1/2 is m over 100 minus x. And these two equations will be everything that I need to figure out what m is. And it'll turn out that once I figure out what m is, I can figure out everything else I need for this problem. So I'm going to take these two equations and note that I have two equations and two unknowns. So if you have two equations and you're trying to solve, or I guess if you have two unknowns and you're trying to solve, you need two different equations. So we can take these two equations and put them together. From this equation, I could solve for x. And why am I going to solve for x and not for m? Well, because I want to know what m is equal to, and I'm going to do this substitution trick. So I'm going to get x all by itself. From this equation, I'm going to multiply both sides by x to get that the square root of 2 times x is equal to 2 times m, if you multiply both sides of the equation by 2 and by x. And from this equation right here, I can get that 100 minus x is equal to 2m. And the same thing, I multiply both sides of the equation by 100 minus x and multiply both sides by 2. I now have these two equations right here. Well, I could set them equal to each other. I have a 2m here and a 2m here, so 100 minus x must be equal to the square root of 2 times x. But if I set them equal to each other, I'd lose my m's and I could only solve for x, which I could then later use to solve for m, but I don't want to go through all those steps. I want to instead solve one of these equations for x. Which one is totally up to you. Maybe I'll solve this one. I'll add x to both sides of the equation and subtract 2m from both sides of the equation to figure out that x is 100 minus 2m. And if x is 100 minus 2m, then over here, when I have the square root of 2 times x, I can instead write the square root of 2 times 100 minus 2m in place of x right here is equal to 2m. So I took this equation and I kind of plugged it in for x right here to solve. So maybe I need another arrow going in that direction. And now I only have one variable, the letter m, so I can solve for it. I get 100 root 2 minus 2 root 2 m is equal to 2m. So if I add 2 root 2m to both sides of the equation, I get 2m plus 2 root 2m is equal to 100 times the square root of 2. And so to solve for m, I'll factor out an m to get 2 plus 2 root 2. And then divide both sides by this 2 plus 2 root 2 thing to get that m is equal to 100 times the square root of 2 divided by 2 plus 2 square root of 2, which if you feel like reducing fractions, you could factor out a 2. You could factor out a 2 root 2. Well, okay, calm down. You could factor out a 2 from the top and the bottom. That would give me 50 root 2 divided by 1 plus root 2. If you don't like having the square root of 2 in the denominator, you could rationalize this. You could go further, but I'm going to go ahead and leave it like this because it does say that my answer can be left as an expression, some big mess like this. And I got square roots in the denominator here, so I'm going to say it's totally fine to leave my answer like this. This is the height of the mountain. I'm not quite done with the problem. I'm done with the first question. It asks me how tall is the peak of the mountain, and then it also asks me how long would a tunnel through the mountain from me to you be. In other words, it's asking me what is, maybe here's a y and here is a z. When I'm trying to solve for the tunnel length is equal to y plus z in my picture. So how can I figure out y and z? Well, I can use the information that I just found. And you could go about this several different ways. You could repeat an argument kind of like you just did, except instead of using x's and m's and the sign, you could use the tangent and to get m's and y's there. Is that the easiest way to go about this? I don't know. Guess we can try it out. So it'll turn out that y is the exact same as m. How do I know that y is the exact same as m? Well, if this is 45 degrees and this is 90 degrees, this is 45 degrees. And if I have an isosceles triangle, meaning the length of the two legs are the same, if I have an isosceles triangle, meaning two of the three angles are the same, then the lengths of those two legs are also the same. So y is equal to m. If you don't buy that logic, the tangent of 45 degrees must be equal to, tangent is opposite over adjacent, so that's m over y. But the tangent of 45 degrees is just 1, so 1 is equal to m over y. In other words, m is equal to y. So this right here, I could have just wrote m if I felt like it. Okay, what about z? Because note that my answer is going to be y plus z, but I just figured out that y is equal to m, and I already know what m is over here. If I could figure out z, I'd be done. Okay, so how could we figure out what z is? Well, the tangent of 30 degrees is opposite m over adjacent z. So what that tells me is, let's see, the tangent of 30, you might have this memorized off your unit circle, you might not. It turns out that it's 1 divided by the square root of 3, or root 3 over 3 if you want to rationalize. So what I can do is solve for z by multiplying both sides by z and by... Let's first multiply both sides by z to get root 3 over 3 z equals m. So to get the z all by itself, I can multiply both sides by 3 divided by the square root of 3 to get 3m over root 3, something like that. So the tunnel length, so I kind of take this information and this information and say that my tunnel length is m, because that's what y is equal to, plus 3m divided by the square root of 3, because that's what z is equal to, and as I said above, my tunnel length is y plus z. So it's this thing right here. You could leave your answer like this, but since I know what m is, I can plug that in. I could say it's 50 square root of 2 divided by 1 plus root 2, plus 3 of these 50 square root of 2 divided by 1 plus root 2 things, Let's see how best to write this. Okay, how about this? 3 divided by root 3 times 50 root 2 over 1 plus root 2. If you wanted to simplify this, you could. Do I say you don't have to simplify? It says leave your answers as expressions. Okay, so I guess I could simplify this if I felt like it. I could, maybe I'll just say or. To get a common denominator, I wish this root 3 weren't here, so I'm going to multiply the top and the bottom here by root 3. But that would make this 3 and cancel out with this 3. What I'm saying is really I have 50 square root of 6 over 1 plus root 2 in this fraction, and 50 square root of 2 over 1 plus root 2 in this fraction. So really it's these two guys I'm adding up. I guess I could factor out a 50 and say I got root 2 plus root 6 divided by 1 plus root 2. I'm sure there's other ways you could write that. Maybe I'll just keep throwing ors in here. But I think any of those would be sufficient. Let's call that good. And say this is my tunnel length. And of course, if you wanted to have actual values for these things, you could throw it into a calculator or something. But as far as I'm concerned, this is better than a decimal approximation that a calculator would give you. So I'm going to leave my answer just like this and end this video here.